In today's lecture, we'll talk about error handling and predictive parsing. We have already discussed how do we do the parsing using predictive parsing table, and we have covered how do we construct predictive parsing table. In today's class, we'll talk about error detection during predictive parsing, and we'll talk about error handling and error recovery during the predictive parsing. If you recall, during predictive parsing, we make use of a stack. At the bottom of the stack, I place $, and the string that is to be parsed is placed in the input buffer. At the end of the input buffer, I place $. Whatever is the content of the stack, that is the expectation of the parser. So if a stack is holding, for example, a small a, capital B, expectation of the parser is that it is first of all expecting a small a, then it is expecting the string which is derivable from capital A, followed by this it is expecting the string derivable from capital B. Now at this state of the parsing, the next input symbol has got to be small a. So whenever I have a terminal symbol on top of the stack, this terminal symbol must match with the next input symbol. If it is not matching with the next input symbol, then this is indicating the error. So in this state, if the next input symbol is a small a, this is okay. But if the next input symbol is not a small a, then this is indicating, or this is generating the error. So there's one condition there's one condition which generates error during the predictive parsing. The second condition is if I have a variable on top of the stack, for example, let us say capital A, and the next input symbol is, for example, a small b, I consult the parsing table for the entry a comma small b, and I find that this entry in the parsing table is a blank entry. So this is generating the error. So there are two conditions under which errors are detected in the predictive parsing. One condition is when I have a terminal on top of the stack and it is not matching with the next input symbol. And the second condition is when I have a variable capital A on top of the stack and the next input symbol is small a, I consult the parsing table for the entry a comma small a and I find that it is a blank entry. So when I consult the parsing table for variable which is on top of the stack and the next input symbol, I find that the corresponding entry in the parsing table is a blank entry that is also generating error. Let us now turn our attention to error recovery. In order to recover from the error, we try to eliminate the erroneous part from the input buffer. So if we are currently parsing an expression, an error is there in that expression, we try to eliminate that expression from the input buffer. If we are currently parsing a statement, an error is there in that statement, we try to eliminate that statement from the input buffer. Let us assume that this is what we currently have in the input buffer, and this is currently the next input symbol, and parser has generated error for this input symbol. And let us also assume that this is the part which is erroneous. So we'll try to eliminate this part from the input buffer in order to recover from the error. And this is the symbol which is following the erroneous part. So in order to recover from the error, we eliminate the erroneous part and we resume the parsing from this symbol. And this symbol is known as synchronizing token or synchronizing symbol. So in the event of error, we look for synchronizing token in the input buffer. Whatever symbols which are there before the synchronizing token, they are assumed to be part of the erroneous portion, and they are skipped or they are eliminated from the input buffer, and the parsing resumes from synchronizing token. This is how this is one strategy that we may adopt in order to recover from the error, and this is known as panic mode recovery strategy. Next question is, how do we identify synchronizing token? In order to understand this, let's take an example. And the example that we are taking is, let us assume that at some point of the parsing, I have capital A, capital B, and dollar in the stack. And this is what we have in the input buffer. What I can derive from this? I can say on the basis of this that symbols which are there in the first of capital B, those symbols will be there in the follow of capital A. And the second thing that I can derive from this is, since the stack is holding capital A and capital B, so I can say that parser is first of all expecting the string derivable from capital A, followed by this it is expecting the string derivable from capital B. So a string which is there in the input buffer can be broken into two components. First component which is derivable from capital A, and the second component which is derivable from capital B. Now, when I consult the parsing table, on top of the stack I have capital A, and this is the next input symbol. So when I consult the parsing table for A comma this symbol, I find that this entry is blank entry. So now parser has generated error. Now this error has occurred in the string derivable from capital A. So in order to recover from the error, what I'll do is I will try to eliminate the erroneous part, and since error has occurred in the string derivable from capital A, I will try to eliminate the string from the input buffer which is derivable from capital A. So this string I will try to eliminate. In order to eliminate this, I must look for the symbol which is there in the follow of capital A. I have already said that the symbol which are there in the first of capital B, they will be there in the follow of capital A. So follow of capital A will act as synchronizing token in this particular situation. So in order to recover from the error, I will look for the symbol which is there in the follow of capital A, and that will be acting as a synchronizing token. In previous slide, we talked about selecting follow as a synchronizing token, but selecting follow as a synchronizing token may not be enough. In order to understand this, let us take an example, and the example that we are taking is A is equal to B plus C D semicolon. And this statement has got an error. Between C and D there is an operator missing. Let us also assume that followed by this I have another statement which is if statement, and this statement is also terminated by semicolon. All the statements are derived from the some variable. So let us assume that there is a variable capital S in the grammar which is deriving the statement. So this statement is derived from the variable capital S. What will be the follow of capital S? All the statements are terminated using semicolon, so the follow of capital S will contain semicolon. In the event of an error, and if I select follow as a synchronizing token, I will look for semicolon in the input buffer, and from this semicolon I will resume the parsing. But by mistake, if this semicolon is also missing, then this will cause all the tokens part of this statement to be skipped, and the parsing will resume from this semicolon. So in such a situation, it is logical to select keyword if as a synchronizing token. So we may also think about selecting keyword from which a new statement can begin to act also as a synchronizing token. So keywords from which a new statement is beginning, that can also act as the synchronizing token. Let's now consider another scenario, and let us assume that I have capital A on top of the stack and I have something in the input buffer. And let us also assume that when I consult the parsing table for the entry a comma, whichever is the next input symbol, I find that it is the blank entry. So at this step, parser has encountered error. What is the meaning of this? Uh, Capital A being on top of the stack, it means that parser is expecting the string derivable from capital A. So at this stage, uh, in the input buffer, there should have been the string which is derivable from capital A. Any string which is derivable from capital A begins from the symbol which is there in the first of capital A. So that means at this step, uh, next input symbol should have been the symbol which is there in the first of capital A. Let us also assume that symbol which is there in the first of capital A is appearing later on in the input buffer. So how can I interpret this particular situation? I can interpret it in this manner, that since at this stage parser is expecting the string derivable from capital A, the string derivable from capital A is appearing later on in the input buffer, and by mistake user has inserted some input symbol before that particular string, and so many input symbols have been inserted by mistake by the programmer. So in order to recover from the error, what I can do is I can skip or eliminate these characters from the input buffer, and I can resume the parsing from the symbol which is there in the first of capital A and appearing later on in the input buffer, and I'll resume the parsing with A being on top of the stack. So what does it mean? It means that the symbol which is there in the first of capital A can also act as the synchronizing token if they are appearing later on in the input buffer, and I find that capital A is there on top of the stack. Let's now consider another situation, and let us assume that I have capital A, capital B on top of the stack, and I have something in the input buffer. Let us also assume that in the parsing table I have entries like this. In the row corresponding to the variable A, let us assume that this particular column is for the terminal symbol A, this column is for the terminal symbol B, and this column is for the terminal symbol C. And let us also assume that the entry at this location in the parsing table is capital A derives epsilon. Entry at this location in the parsing table is capital A derives alpha, and this entry is a blank entry. So when capital A is on top of the stack and next input symbol is a small a, this is denoting the error condition, and parser has encountered error in this particular situation. If capital A is on top of the stack and the next input symbol is a small c, what does it mean? It means that capital A will be expanded using epsilon. So capital A will be replaced with epsilon, and the capital B will be coming on top of the stack. In that particular situation, this string is supposed to be derivable from capital B. So that means when capital A is on top of the stack and next input symbol is a small c, the string that we have in the input buffer is actually derivable from capital B. Question now is, how do we recover from this particular error when capital A is on top of the stack and the next input symbol is small a? I can assume that the string for this situation also, I can assume that the string that we have in the input buffer is supposed to be derivable from capital B, and this string should actually begin from C, but it is actually beginning from a small a. So there is actually an error in the string derivable from capital B. So I can I can expand capital A with epsilon. So I can replace and expand capital A with epsilon, and I can use this particular production as default for handling and recovering from this particular error. So here I'm using a production in order to recover from the error. So as of now, like this particular error will be caught later when I consult the parsing table for the entry b comma whatever is the next symbol. There are two conditions which give rise to error during parsing. One is when I have a variable on top of the stack, and when I consult the parsing table for the topmost variable on the stack and the next input symbol, I find that the corresponding entry in the parsing table is a blank entry. So this is denoting the error condition. How do we handle and recover from such error? We have already discussed this in the previous slide. The second condition which give rise to error during parsing is when I have terminal symbol on top of the stack and this terminal symbol is not matching with the next input symbol which is there in the input buffer. So this is also denoting the error condition. In order to handle such error, what I'll do is that I will pop the terminal symbol from the stack and I will issue a message to the user that terminal symbol, for example, small a was inserted. If I handle the error in this manner, what is my assumption? My assumption is that when a small a is on top of the stack, parser is expecting the terminal symbol small a in the input buffer, rather some other terminal symbol has come. So this terminal symbol was probably missing from the input buffer, so this was inserted. That is the message that was given to the user programmer, and by popping this from the stack, the parser continued parsing. Let's now take an example of error recovery. In the example, first of all, we'll talk about error recovery strategy, and then we'll take an erroneous input and we'll do the parsing of the erroneous input, and we'll learn how do we recover from the error and how do we parse incorrect string. The example that we are taking is this grammar, and this is the predictive parsing table for this grammar. I had already given you this grammar and we had already obtained this predictive parsing table in the previous lecture. This grammar accepts arithmetic expression, and this is non-recursive grammar. This grammar has got variable capital E, E dash, capital T, T dash, and capital F, and the follow of these variables are shown in these two tables. So follow of the variable capital E is right parenthesis and dollar, and so on. Now my error recovery strategy is based upon the idea of selecting follow as the synchronizing token. So follow of the variable capital E is right parenthesis and dollar. So these two symbols will be the synchronizing token for the variable capital E. Similarly, follow of the variable capital T is plus right parenthesis and dollar. So these three symbols will be the synchronizing token for the variable capital T. And I am also marking synchronizing token in the predictive parsing table. So these two symbols are synchronizing token for the variable capital E. So E comma right parenthesis and E comma dollar, they have been marked as sync entry in the predictive parsing table. Similarly, these three symbols are synchronizing token for the variable capital T. So they are marked as sync in the predictive parsing table, plus right parenthesis and dollar. We'll come back to E dash and the variable T dash a bit later. For the variable capital F, these are synchronizing token and they are marked in the predictive parsing table as sync. These entries are marked as sync. Now when I look at the variable E dash, their follow is right parenthesis and dollar. So synchronizing token is right parenthesis and dollar. But when I consult the parsing table, I already find that they are containing the production E dash derives epsilon, and here also they are containing, it is containing E dash derives epsilon. So since it is already containing a production, so I cannot mark these entries as sync entry. And similarly for the variable T dash also, When I look at the parsing table at these locations, I am already having a production, so I cannot mark these entries as sync entry. Now my error recovery strategy is like this. Let us say I have capital A on top of the stack and the next input symbol is small a. When I consult the parsing table for the entry a comma small a, I find that this entry is blank entry. So this is denoting the error condition. What does predictive parser do in the event of error? We discussed it short while ago. In the event of an error, predictive parser skips input symbol till it finds the symbol which is the synchronizing token, and when synchronizing token is found, it pops the terminal from the stack. So in this case also, for this state of the parser, where capital A is on top of the stack and the next input symbol is small a and this entry is blank in the predictive parsing table, I will skip this particular input symbol. So this small a will be skipped. On the other hand, if A is synchronizing token, then capital A will be popped from the stack. Now the second condition which denotes error in the predictive parsing is that the terminal on top of the stack is not matching with the next input symbol. In this case, I will simply pop the terminal from the stack. So this is my error recovery strategy that I will use in the parsing. Let's now take the example of an incorrect string and do the parsing for the string. The string that we have taken is this one, id star plus id, and there is error in this string. So I place this string in the input buffer, and this is the content of the stack. We are starting with capital E on top of the stack, which is a starting variable, and at the bottom I have $. So I consult the parsing table for the entry e comma identifier. E comma id is containing this production, so capital E will be expanded with TE dash. So we have expanded capital E with TE dash. Buffer holds id star plus id $. We consult now parsing table for t comma identifier. T comma identifier is containing this production, so capital T will be expanded with ft dash. So capital T has been expanded with ft dash. I consult the parsing table for f comma identifier. It is containing this production, so capital F has been expanded with identifier. Now topmost stack alphabet is a terminal symbol and it is matching with the next input symbol. So this will be popped off from the stack and it will be eliminated from the input buffer. I consult the parsing table now for the entry t dash comma star. T dash comma star is containing this production. So t dash will be expanded with star ft dash. So t dash has been expanded with star ft dash. Now once again, the topmost stack alphabet is star, which is a terminal symbol, and it is matching with the next input symbol, so it will be eliminated from both the places. Now we reach this configuration of the parser. I consult the parsing table for if comma plus. If comma plus is containing a sync entry. So now there is error. This error will be reported, and since it is marked as sync entry, so capital F will be popped off from the stack. So this has been popped from the stack. Now t dash comma plus is containing this production. T dash will be replaced with epsilon. So t dash has been replaced with epsilon, and now we reach here. And this way the parsing will go on and continue.